Hello, families. It's Miss Dominique. First and foremost, I hope that you and yours are safe and healthy. Today, we're going to dive in and we're going to focus on line plots. Specifically, how do we figure out and make a really strong number line? I've heard from teachers these are things that you guys are struggling with, so I hope this video helps. So, great mathematicians like us create a number line for their line plots by thinking, what's the smallest measurement in my data set? What's the largest measurement in my data set? What are the closest whole numbers? That can be my endpoints because we always have whole number endpoints. And what are all the endpoints between those? What are all the measurements between those two endpoints? Here's our problem. And I'm just going to make the number line. So Delia stops under a silver maple tree and collects leaves. At home, she measures the width of the leaves to the nearest 1/4 inch and records the measurements as shown below. Use the data to draw a line plot, then answering the following questions. I'm only going to make the number line. Okay. Let's try that all over again, because I got to make a straight line. Do my best. It looks more like a hill, but you guys work with me, okay? So first I'm going to look at my data set in the table and I'm going to think, what is my smallest measurement? It's looking like my smallest measurement is 5.5. Okay, and let me look, what's my largest measurement? What's the biggest measurement in here? It's looking like it's 6 3/4. Well, on a line plot, you can never have a start or end point that's not a whole number. So let me think, what's the closest whole numbers to those two numbers? Well, 5.5 is close to 5. So that can be my lower endpoint, the start. Then 6 3/4, well, it can't be 6 because then all the things that come after 6 wouldn't fit on my line plot. So I must go up to 7. Okay. So when I think about what are all the measurements in between there, it's anything from 5 to 7. When I look at this data, up in the story, it says we're measuring to the nearest 1/4 inch. And I see that they have 3/4 inches, 1/2 inches, and things like that. So I'm going to partition my number line into quarter intervals. So first, just like with fractions, I'm going to put my whole numbers on. So I got 5, I got 7. What becomes between 5 and 7? Yes, 6. So I'm going to put a 6 here. Then, because we're measuring to the 1/4 inch, I'm going to partition each whole into 4 equal parts. Then label it. So I did half, then half again. That's an easy way to make 4, so we use our related fractions. Now I'm going to label. So here I'm going to put 5 1/4. Then let me think, what comes next? Well, am I counting out by fourths? That's 5 2/4. But I don't see 5 2/4 here. Oh, I can use what I know about related fractions and equivalencies. I know 5 2/4 is the same thing as 5.5. I'm going to write that instead, 5.5. I want you to think, what would come next? Yeah, so I'm measuring by 1/4 inch. So 5.5 is 2/4. So 2/4 plus 1/4, that's 5 3/4. And I would do the same thinking to write the endpoints, the tick marks for each tick mark on my line plot. So after doing all that thinking, this is what the number line on my line plot would look like. It would start at 5, end at 7. It would increase by quarter intervals. I know anything that's equal to something in 2/4, that's equivalent to something and a half. Let's do another one. Here's it. It says Tesha measured the distance from her house to several locations to the half kilometer. Here's the distance and number of places. Now I'm just working on the line plot part. So let's do that again. So I'm looking at the data. I'm thinking about what's the smallest measurement, what's the largest measurement. Oh, this is easy because it's very well organized. So the smallest is 2, the biggest is 5.5. Let me think, what are the closest whole numbers? 2. 5 is not big enough, so we have to go to 6. So I need to fit 3, 4, 5. I need 3 holes. 2 to 3, 3 to 4, 3, 3 to 4, 3. Let's see. So I need to fit a bunch of whole numbers on here. So I partitioned it to put my holes first. So 2, 3, then 4, then 5, then 6. Now let me think, what are all the measurements between those endpoints? It goes from 2 to 6. So I put my holes first, and let me think, based on the data, what should my intervals be? How should I partition each hole? It looks like since we're measuring to the closest half kilometer, I should partition each hole into half. So I partition each hole into half. And then I think, what should I label this? Well, if I'm counting by halves, it'd be 2.5. Then I would keep going. So 2.5, then 3, then 3.5, then 4. Then here would go 4.5, then 5, then 5.5, then 6. Note there are some numbers on here that might have no data. Remember, every time we're trying to create a number line for your line plots, think, what's the smallest measurement in my data? What's the largest measurement in my data set? What are the closest whole numbers that can be my endpoint? What are all the measurements between those endpoints? Think, what are the whole numbers first? Mark those. Then break up each whole into your fractional parts. Use what you know about fractions. Here's one more problem. I want you to pause the video and think, what would the number line look for this problem? Do it, and then when you're ready, press play on the video to see the reveal. Welcome back. So by now you should have created the number line for your line plot. Compare yours to mine. Are they the same? If not, think, what do you have to do differently? If you think you're ready, explain to you. You should be able to explain, why does my number line start at 0 and end at 3? Why did I write 1/2 and not 2/4? I hope you guys found this helpful. Remember, great mathematicians create number lines for their line plots by thinking, what's the smallest measurement in my data set? What's the largest measurement in my data set? What are the closest whole numbers that can be my endpoints? What are all the measurements between those endpoints? It's easiest to start with the whole numbers, mark those off, then partition each whole number into equal intervals based on what you're measuring. I hope this was helpful. Thank you so much. Bye-bye.